Another way to graphically investigate the distribution of one variable is the box plot. And we often use the box plot to check for outliers in our data. These are extreme values that we have to pay extra attention to. And we use the ordinary figure object, the axis object, and we are using the subplots function here from the pyplots package or the matplotlib package. And now we are going to populate the axis with the boxplot method. And if we just put data and we are still looking at price, then we shift enter that and we have the box plot. And what does this mean? Well, it means that this bar here, this line, this is the median value in the dataset. Not the mean, but the median. These, or this box, as the box plot is named after, this is the interquartile range, which means that this is the first quartile, this is the third quartile, so 25% of the data is below this, 75% of the data is below this one, which means that 50% of the data is inside of the values here and here. These lines should be this interquartile range times 1.5, and these and if you have any data points outside of these maximum and minimum bars here, then you would have them represented as dots. And then you should investigate these data points thoroughly, just to make sure that they are proper data points and not some random errors. Right now, we do not have much information in this figure because we should be able to immediately see what kind of information we have. So we should set a title, and this should be, let's see here, we should, for example, set title price as such. So now anyone looking at the figure can see that we are actually representing the price here. But what we could do is to have several box plots in one figure. And this is very nice to look at the distribution between different groups. So we just start with the ordinary figure and axis. We make use of these subplots, but now we should have number of columns should be equal to 2. So now we are going to put these beside each other because the number of columns should be 2. Okay, what do we also need to remember? We need to remember that when we are populating these, then we specify the axis position, which is either 0 or 1. So the first figure or the first plot is a box plot, and the data is price, and we are going to subset on data city is equal to Oslo. So now we have subsetted the data, and we need to make another one. So this is in position 1, index 1, and data price, and we are subsetting on data city equal to Trondheim. Okay, so now we have made this figure. We can run it, and we see that, well, we have two figures, but we do not know which one is which just by looking at the figure. So now we have to have some titles. So x0, always remember the index when you are looking at subplots. Set title, and that should be Oslo, and we can make another one. Axis 1, set title, and Trondheim. If we run this, well, now we see that this distribution is for Oslo and this distribution is for Trondheim. But the problem now is that they are really, well, they are not that easy to compare because the y-axis here is different between they are different between the two plots. So we can specify here y equals to true. So here the Boolean value comes into play. And here we have the same y-axis on the two different box plots, which means that you can easily compare these two plots. And of course, we can, I like to specify the pig size, so it's larger than the ordinary pig size, because then it's a bit better. So this is how you can compare two different distributions from two different groups.